Our lesson today about comparing the measures of angles in a triangle. Comparing, it means greater than or smaller than these two signs which we'll use in this lesson or in this unit. We have a theorem, the first theorem in the inequality in a triangle. If two sides have unequal length, what does it mean? It means that one of these two sides is smaller than or greater than the other. So the longer side is opposite to the angle of the greater measure. So the longest side opposite to the greatest angle. Why? To understand why, look at this triangle ABC, this triangle. In this triangle, we want to prove that measure of angle ACB, this angle, is greater than this angle. So to prove that, we'll do a construction, which is we'll put D on the line AB, on the side AB, where AD equals to AC. Now we have an isosceles triangle, which is ADC. This triangle is an isosceles triangle, so angle ADC equal angle ACD. These two angles are equal. Angle ADC is an exterior angle of a triangle DBC. So measure of angle ADC greater than measure of angle B, because we know that any triangle and then in the exterior angle is greater than any angle in the triangle except the adjacent angle. From 1 and 2, which we said that we have two equal angles and the exterior angle is greater than the interior angle, so we can say that angle BC equal greater than angle B. You have to know that the greatest angle in measure of the triangle is opposite to the longest side of the triangle, and its measure is greater than 60 degrees, and the smallest angle in measure of the triangle is opposite to the shortest side of the triangle, and its measure is less than 60 degrees. Example 1. In the opposite figure, ABCD is a quadrilateral in which AB equals 5 centimeters, BC equals 2 centimeters, and DC equals 3, and AD equals 4 centimeters. We want to prove that measure of angle DCB, this angle, is greater than angle A. Now, we are talking about the triangles, so we'll divide the quadrilateral into two triangles. So we'll do a construction. We'll divide it we will draw a line to join the two angles, vertices A and C, and we'll draw a line or a side AC. Now, we have in this triangle, we have two triangles, ADC and ABC. In the first one, ADC, we have AD greater than AD, this side is greater than DC, so the greatest side opposite to the greatest angle, so angle CADCA, this angle is greater than this one. And this is the first part of the question. The second part, in the triangle ABC, we have AB greater than BC because it's the longest side opposite to the greatest angle, so angle C is greater than BCA is greater than BAC. From 1 and 2, we can say by adding 1 and 2, these two angles together, we'll get that angle C greater than angle A. Example 2. ABC is a triangle in which AB greater than AC and angle BAC is bisected by AD, which intersects BC at D. Prove that triangle ABD is an obtuse angled triangle. Here we don't have a figure, so we have firstly draw the figure to this question to be able to solve it. So we'll draw it. Now we want to prove that the triangle ABD, this one, this triangle, is greater than is an obtuse angled triangle. So in the triangle ABC, the greater one, we have AB greater than AC as he told me. So angle C is greater than, so angle C is greater than angle B because it's opposite to the longest side. AD bisects angle BAC, so we have angle BAD greater than, equal DAC. Now, if we add angle C plus angle CAD and angle B to the angle BAD, as you see that we numbered it 1, 2, 3. So, but measure of angle C plus angle CAD equals measure of angle ADB because it's exterior angle. This angle ADB is an exterior angle, so it's equal to the sum of the two opposite angles in the triangle. So because of angle ADB is an exterior angle of triangle ADC. So angle ADB greater than angle B plus angle BAD. So for that reason, this triangle ABD is an obtuse angled triangle.